Hello and welcome to this video. Today we're going to try to explain to you something new about electrical engineering in the field of study digital and microcomputer electronics. I'm going to explain to you what can you learn in this field, what skills are essential to be successful in this major, and how can you apply the fundamentals of electrical engineering in the real world. Is the digital and microcomputer electronics the right choice for you? Digital electronics is that branch of electronics which deals with digital signals to perform various tasks and meet various requirements. It is based upon the digital design methodologies and consists of digital circuits, integrated circuits, and logic gates. It uses only binary digits, either zeros or ones. The microcomputer electronics deals with microcomputer, microprocessors, and microcontrollers' internal structures, building parts, and organizations of signals. The objective of digital and microcomputer electronics is to enable students to design and simulate simple digital electronic systems and functional units of microprocessors and understanding the structure, operation principles, specification and design of simple microcomputer systems. In this field you can learn what is the difference between digital and analog signals, what is a digital electronics, what are the logic gates, and what can you create using this knowledge. The computer you are using to read this page uses a microprocessor to do its work. The microprocessor is the heart of any normal computer. The microprocessor you are using might be a Pentium, a K6, a PowerPC, Spark, Intel, or any of the many other brands and types of microprocessors. The difference between digital and analog signals. Digital signals vary in steps. They have a finite and well-defined values in a range. Analog signals vary continuously in time and have infinite values in a range. For example, digital signals can be transmitted using zeros and ones, while analog signals can be, for example, daily temperature, wind speed, daily humidity, air humidity, and so on. You may have heard about this concept. In a digital TV broadcasting systems, analog signal, if it is weak, the picture on our TV set will be weak and it has a lots of static. Versus the digital, as long as the TV set is receiving a signal, the picture stays perfect. Almost every country today in the world tries to convert from old analog signals to digital signals for broadcasting. The advantage of the digital systems is that we can have a multiple compressed digital channels on our TV set. While with the analog signal, we can have only one single television channel. You will learn what are the microprocessors, and you're gonna study the internal structures of central processing units, of registries, and logic gates, and how to create a simple microprocessor. You are gonna learn some math skills like Boolean algebra in order an application of Boolean algebra in order to create circuits and diagrams. We were going to learn what are the logic gates, the basic logic gates, and how can you apply this knowledge to create more complex structures. Logic gates are the basic blocks of the digital circuits. There are basic gates of three types: AND, OR, and NOT. Two universal gates are made of these three basic gates, which are NAND and NOR gate. These gates are the functional blocks of digital circuits which work upon making combinations of zeros and ones. These are the subcomponents of the integrated circuits. Combining these gates, we get integrated circuits, and combining them with other electronic gates, we create complex systems like motherboards for PCs, laptops, tablets, or mobile phones, including smartphones. In this example, the AND logic gate gives 1 as its output only if the both inputs are on. In this example, the light bulb will shine if the both switches are on. We can see on this example on a binary coded decimal to 7-segment display. We were going to learn how to apply Boolean algebra laws in order to create an output from 0 to 9 on a 7-segment display. First, you will learn how to create truth table and how to arrange basic logic blocks or gates in order to make the circuit work as you desire. You will gonna combine logic gates together, and at the end you will gonna combine all the electronic parts, and using only switches, 4 of them, you will be able to control an output on a 7-segment display. Depending on which switch you activate, your output number will be from 0 to 9. And in this field, you can master how to make complicated structures like human machine interfaces. These human machine interfaces can be found inside of cars, inside of museums, like digital visitor for digital visual visitor experiences, and inside of the companies, industries for controlling the machines. This is just a small representation of what can you learn and study in this field. There are many more interesting things to learn here, like how to program a PC, how to control devices over long distances, how to make cool electronic equipment, etc. Inform yourself on the internet, and good luck.